Okay guys, so couple of things I want to go through here, right? First thing first, let me see that I can hear myself. Okay, excelente. Okay, so with 7950X3D, it's been, for the lack of a better word, it's been a disaster, bro. Like, but we got it fucking fixed, man. You know. So I think, I think So I want to give you a little prehistory. Prehistory is the last two 3900Ks to the Raptor Lake fucking conspiracy, and just I'm pretty sophisticated as far as overclocking, undervolting, and I actually didn't overclock. I just undervolted. I limited the cores. One chip went down at 6 months marker. I replaced that chip. Was another one, and then that chip broke around 6 months again in the same exact fashion. So I contacted Intel. Intel was pretty cool. Intel, I actually have no issues with them, and I have a lot of respect for Intel actually. So I'm sorry for the losses as of now. You know, it's really unfortunate, guys. You know, but my journey with 7950X3D started from a standpoint of hate, because I was like, hey man, what's going on with this two CCDs? Like, well, what's up with the scores going, you know, on two separate chiplets? You know, it's just regular bullshit, you know. But after all this, right, I buy 7950X3D kind of being forced, honestly, because I didn't want to buy 3900K or get it RMA'd again, you know, because it was just, it's too much of a gamble that I might have the same situation as the previous two chips, because they both failed in the same exact fashion. And I knew about all of this well ahead of time, like way ahead of the scandals. I was already experiencing this, and I found ways how to mitigate it. Theoretically, of course, by limiting the cores. I did what? Limits. I did pin cores. I didn't have any boosts and stuff. And that in itself led me to 7950X3D. So now you understand. So once I got 7950X3D, I was very hopeful because I understood what process lasso is. Process lasso is just a common application to me nowadays, because I actually used it quite a lot with 3900K. Because I found some ways how you can mitigate stutter, and I was disabling hyperthreading, but just for the P cores, but then leaving E cores alive with all the hyperthreading that had. So I left it as such, but then I found different like workarounds, and I did a bunch of tests, a bunch of latency tests and stuff like that. Checked the FPS, and I found the drivers. Here's what I've gathered so far with 7950X3D. Windows 11 is, I'm trying not to say anything messed up, but Windows 11 is horrible. Windows 11 has a scheduling issues with Intel and AMD CPUs. So it's not just specific to AMD. People like frame chasers love to say that the fact that AMD got the dip, it's AM dip. Alright, bro. But did you test Windows 10 though? I bet you didn't. So here's me with all of my bullshit, right? Like with all of my latency and all those AM dips and whatever, right? I'm the kind of guy who doesn't take no for an answer at the face value. I knew something was wrong here, but on a deeper level, because I was like, well, if I limit the two CCDs, I just use one CCD, I disable the other, it should work fine because I dealt with Intel, right? The problem here is Windows 11, which leads me to believe that Windows 11 is causing stutter issues on 3900K and those CPUs as well. And the way that I found how to mitigate it, like I said, is a hyperthreading. But that was Intel. With 7950X3D, the issues were much more complicated, because when, let's say, I take whatever application is, just for the sake of it, let's say I do process lasso here. And by the way, process lasso, you should select just the CCD1, which is a non-3D. So technically all those cores here need to be disabled, but for now it works fine. I will disable this later. I will disable these cores here later. But let's say I want to run just this course, which is 3D cache course. You would just deselect this. Here's a problem. A lot of times the system, if it's, let's say, if it's set in auto, or if it's set in a frequency based, like a frequency preference and bias, that stuff matters, but this cores will kick in as well. And in case of games like Red Dead Redemption, it's fine. It's like it's working, but it's working fine. But these cores are not off. Now, if I was to do a cache-based preference, then it will actually allow these cores to be activated by themselves. And this cores will stay idle during the games, but I have to process lasso. So I have to process lasso, let's say a game in the same fashion. So I'll just keep this cores on and turn off this cores. In that case, all these cores will be turned off just for the game. That in itself right there will alleviate about like 90% of your stutters, but not completely. And that's even Windows 11. So what I've done is I did this. Did I do it right? No, I didn't do it right. I need to go like this. So in this scenario, you have main cores that are 3D on. So 1, 2, 3, 4, 5, 6, 7, 8. So it's first 8 cores minus the hyperthreading, which is 1, 9, 3, 11, 5, 13, 7, and 15. And that in itself will solve most of your stutters, and your, like for example, Red Dead Redemption 2 will work excellent. Here's a caveat though. Games like Insurgency Sandstorm, they don't care about the cache as much as frequency and as much as many cores. So literally you can have all the cores, including hyperthreading, turned on, and you'll have pretty good performance, pretty stable, with an occasional stutter, but that's just the nature of the game, plus it's the nature of Windows 11. We're still talking about Windows 11, mind you. Now let's say if I was to do this, I'm disabling hyperthreading cores, but leaving all the cores on, and let's say I do cache preferred, it's still gonna be really good. If I do frequency preferred and bias, still gonna be pretty good. That combination right there is gonna be pretty darn good in alleviating the stutters. But if I was to turn off the CCD1, which is the non-3D, and leave just 3D cache cores with cores but without hyperthreading, so this scenario, this works okay, but it has enough stutters not to be enjoyable. If you enable this, you'll have more stutters in that game. Here's a caveat. You do this here in that game, and almost all your stutters go away, even though 2 CCDs are communicating through Infinity Fabric here. Right? Doesn't really make sense, because Infinity Fabric adds latency, but it doesn't matter in this game. So what I found also from Red Dead Redemption 2 testing, disabling hyperthreading will allow games that are frequency based and the ones who like cores, like lots of cores, to work better if you disable the hyperthreading. Hyperthreading is, I don't want to say it's garbage, because for actual applications within Windows, it is excellent. And you should have hyperthreading on this course, you know. But for games don't like them. Whether it's 3D cache, whether it's, oh, I'm sorry, didn't select that one. Did not select it. So there you go. But the games that don't like them, they don't like hyperthreading for whatever reason. I think it's just because it splits the core and like the structure of it. I'm not really fully comprehending it, but I understand that it kind of splits the core into two. So to have the core remain as one is better. Here's another kicker with 7950X3D. So you got this, right? In, like, say, Red Dead Redemption. Works real good. So it's all 3D cores, but without hyperthreading. Now we do opposite. We select the hyperthreading cores, right? See it? So opposite, not 0 and 8, not the even amounts, but the odd amounts. 1, 9, 3, 11, 5, 13, 7, 15. This actually works really good. Super interesting. So it's like, it doesn't matter which core as long as you disable the other portion. And then it works really good. It works about as equal, if not equal, to if I was select 0, 8, 2, 10, 4, 12, 6, 14, but turn off the ones that are on right now. Weird, but interesting. So then you have another combination, like this. Still talking about Red Dead Redemption. This combination actually yields a lot of stability. You have 3D cache completely turned off. So these cores are not going to be used. You throw in the game on a quote-unquote slow CCD1, not CCD0, CCD1. And this works amazingly stable as well. So it's a mindfuck. You go like, how does that make sense? But the problem with Windows 11, regardless which setting you're going to pick, there is a lot of drops. There's a lot of drops in frame-to-frame latency. So here you have, just I'm going to find you some example, for example. Okay, let's see. It's Windows 10. This is Windows 11, for example. So in most cases, this is pretty good. You see how it's like jumping around here at, I wish I would just render stuff better on YouTube. YouTube just craps it out. This is good. This is, here in particular, what I did was I selected just 3D cores, but I ran this course here specifically with no hyperthreading. So just 3D cores. And you can see how flat it is. But here's what I noticed. On Windows 11, occasionally this will begin to crap out. So right now it's like 6.7, see, like 9. 9 is okay. 9.2, 9.1, that's okay. Because it's still within like a 3 millisecond range. Because you would, oh, see right there, 15? When I jump to 15, that's bad. And I understand once you move like 12, like you have cutscenes in between. The problem with Windows 11, those bursts, they're much more consistent. And look at the FPS. You have, this is current, this is average. And this is 0.1% lows. You can see it's 68. But the average, see, like I jumped up for a second, but it's like 53. It can go to up to like 42. That's really low. Jumping from 191 average to, see, it's like 102, then a 56. So it evens out like it does calculations on the fly. But that, you can feel it. Like it's kind of weird. Like when you play a game, you can't really see it, but you can feel it because it's almost like you lose input to your mouse. Like look, Hanatori. I'll leave this video here for now. Then we take a look at Windows 10. So that was Windows 11. This is Windows 11. This is Windows 10. Let me see if I can find a scenario. Okay, perfect. So let's see. This is 3D core selected only, hyperthreading off. Same scenario as this. Come on, load for me. Sorry. Okay, so did a fresh restart. Let's give this a shot, right? Should fix it. Because restarts solve everything. Let's go here. Around. Oh, look at that. Oh, no, still doing slow motion. Look at that slow motion. Flow motion. Slow motion. Homie, what the fuck? Alright, well, we're gonna work around this shit, man. I'm gonna figure this shit out later, man. We're gonna do some backwards engineering on that shit later, man. But so this is CPU one, right? This is like a this is 3D core, but no hyperthreading. You see, this one's disabled, this one disabled, this one bloop, 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 bloop. So this core is so fucking weird, man. But okay, now it's kind of cinematic now. Look at this. Look how cinematic it is, man. Bang, man. Chitty, 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 bang, bang. And I suck at aiming clearly, but thank God for bullet time. Now we got this. Look at first of all, let me see. This is Windows 10. So this is Windows 10. Look at the averages. This is average right there. This is current. It's comparable. This is actually less, and I've noticed it's consistently less in current FPS, and the averages eventually will go below Windows 11 consistently. This is, I believe this is low, and this is 0.1%. So this is, well, this is 1%, and this is 0.1%. Look at this, 119. Pretty big difference. From as low as 42 to 119. And it kind of just updates as it just averages. You can see here it's 115, 116. So it takes a calculation as it averages out. That is incredible, guys. And that's what it's supposed to be, right? Like, I don't know why the video, I think, like right now, by the way, this is running off 3D cache preference and bias. So it's not utilizing frequency cores as much. So I'm doing different testing and stuff just to make sure as I do a bunch of scheduling. Here, what I've noticed, like in the snow area, the grizzlies, is actually a high FPS. And with Windows 11, it'll go up to like 221, which is incredible. But latency, the frame-to-frame latency will never be as good. Look at this, 3.7, 5, 4.8, 3.7, 4.9. You don't see any like jumps to even 9, let alone 12 or 16 or 20 like Windows 11 does. Alright, so look at this. All this shit. And you can kind of see like there is not a single value that I can see even like through the cutscenes and stuff. There is no bad values, man. Actually, the fact of the matter is, guys, right? Because I'm an objective kind of guy. I was an Intel for 12 years, and 14 years or 13 years before that, I was an AMD exclusively. So I don't have like a horse in a race here. But you can see the difference. Here's the difference. The reason why I'm saying I don't have a horse in the race, I'm not biased. I'm not selling services to fist pump for AMD or Intel. I respect those companies. But when you get the graph this flat, like look at the flatness of that graph. Where is a single stutter? This right here, this is Windows 10. This right here is better than Intel 13900K. And I'm sorry guys, like my biggest thing with people like frame chasers is he'll say something like, oh my god, this is like dog shit. And I literally will like write down there like, but what about this on Intel? Like I'll write it down as I'm the Intel user at that time. He'll just like, bloop, delete it. And I'd be like, where's my comment? Oh, it's fucking gone. So also kind of with frame chasers, like as much as I appreciate his channel for information, like actual legit information when he does the testing, he doesn't dive into it. Because here's the thing, when you base everybody else's builds on Intel, you're not interested in doing the AMD build. Like even his latest 9950X like video that he was talking about, it was pretty much kind of like, oh my god, 9950X is so actually incredible. It's actually the best AMD processor that they put out, and in the future I'm gonna buy the ProArt X670E because it got all these lanes, and you get the throughput through the the Thunderbolt, and like NVMe at 5.0, then you got the card at 5.0, you got all those extra lanes. And then he goes, but actually I'm not sure if I'm gonna keep the 9950X because it's too expensive. It's like, homie, what? So essentially, when you have channels like that, unfortunately, even though they're informative channels on many degrees, right, you cannot get an objective point of view. My objective point of view, this graph right there is flatter than Intel. It's flatter than Intel 13900K using RTX 4090, same as this system, and this is better. No subjectiveness here. It's objectiveness. I cannot get the graph this steady, and this is just 3D cores with no hyper-threading. So it allows me to allocate all these cores here, you see, right, to anything else. I can run whatever. I can render a video in the background for all I care, and it'll be fine. The thing that concerns me with Windows 10, GPU usage is less. So while GPU usage on Windows 11 hovers around like 92, 90, 94, here hovers around like 88 to like 86%. Once in a while, I'll go to like 90, 91, but not that often. So this Windows 10 tests. Let me demonstrate. Let's see if that video is actually gonna load, because I have a speculations because the so this is that. Let me see. It's Windows 11. So this is this is Windows 11. Yep. This is same exact setup. You can see frame to frame is higher, dips are lower. It's actually, this one was actually a pretty good run. Yeah, I didn't have a lot of stuff on this one. But recently, it's becoming worse and worse. To the point that I'm getting blue screens, I'm getting black screens, I'm getting hard locks. And that's all happening on Windows 11. So people like frame chasers, they don't discuss a simple thing. The simple thing is this. There's something wrong with Windows 11. And that goes for both CPUs. 3900K is suffering on this, 4900K is suffering on this, AMD is suffering on this. So essentially, both of the CPUs are having inherent issues from the looks of it. But in fact is the frame-to-frame latency bump, the frame-to-frame pacing, why it goes to dog shit and it drops to 70, 62, 42 on both CPUs at times, is because there is something wrong with scheduling. The difference between Intel and AMD, Intel worked directly with Microsoft for years, to the point that Microsoft and Intel are buddies. So this is why AMD does not have enough power to get the game in proper fucking conditions. See, 105? 105 is actually, is about more or less a low 0.1% on 3900K and the same RTX 4090 that I have. Same identical. So about 105. And that's Windows 11. This is Windows 11, but it's dropped into 63. 58, like I've seen 42. 42 is the worst. So it's wildly consistent. So after I installed Windows 10 just to test, because of the hardware unboxed and some other channels kind of talking about it, I was like, this is bullshit. But alas, see, it's kind of like hovering around 205. If I was to play it on the Windows 10, same map, same everything, I'll be hovering around 211. That's excellent. See, this is why I missed this shit. I've missed Windows 11 already because of this. On Windows 10, I'm getting like 180, 175 in the same areas where I'm getting about 15 to 25 frames more. Same exact settings. And I don't get those drops. And you can see it in like this example. It's 116, man. That's a big difference. And it doesn't take much. You guys can go download Windows 10, do a clean install. And once you do the clean install, I don't even think you need to put in your code. As long as you have a same version of Windows, it'll just automatically take it. In my case, it takes it. If not, just put in the code again. And this is one configuration that works every time, for this game specifically. So now I'm scared to upgrade back to Windows 11, because that frame to frame is going to be bad again. Look at this. 4.0, 4.1, 5.2, 4.8, 4.6, 3.0. That's amazing, man. Like, obviously there's different areas, but here you go. He's closer to that same area, actually. This is like close to Valentine. 5.9, 6.7, 4.6, right? 6.0. Let's see, does it go anywhere close to 12? Because I haven't seen it. It's actually cool that it's doing it in slow motion, so we can actually examine the fluctuations. 7.4, okay. I think I seen like the closest was like to 9, like a heavy scene. This is hyper-threading disabled. So let's see. Let's put to like when I was engaging enemies. 5.2, 5.0, 6.1. What I've noticed with 3D cache in general, though, right? And that's something that people don't really want to talk about, right? Like, the thing about 3D cache, what I find really, really interesting, is 3D cache can actually handle a lot of stuff at the same time, which Intel cannot do. And I've noticed that, and like, this is no hate to Intel, because I've been on Intel for so long. The issue here, when you have a lot of shit going on, say you're getting shot, shit is blowing up around you, AMD CPUs, specifically like 7950X and 7950X3D, they handle that action extremely well. When you get killed, for example, in Insurgency Sandstorm on a 3900K, you'll get a jump in latency or a drop in FPS, and you're just like kind of like flung like from the same position with a short delay. And this situation here, you do not. So there is benefit to 7950X and 7950X3D that I don't quite understand. As long as you properly allocate the cores. I would not run hyper-threading on 3D cache cores, because you will get the status. And I released a separate video that you can take a look at it here, like deep dive into affinity scheduling. I don't want you to misunderstand me too. Like, enabling all the hyper-threading doesn't necessarily mean the game is gonna run like garbage, but you're gonna feel it. And that's the thing about it. How much of the feel can you take? Let's see. So this is CCD on. That might be it. Like this is a bad scenario. First of all, let me show you. This is a bad scenario. Running just all cores for the non-3D and having hyper-threading on. But once you turn that off, like the odd cores, 1725, 1927, it all becomes normal again, like you're playing on a 3D cache. And there's literally barely any difference. Anyway, I suggest you guys take a look at it. It's CCD test 3, 2, and 1. This right there. Go through it, take a look at it, and just pick the one that you think looks best. To me, it seems like it doesn't really matter as long as your hyper threading is turned off. And the difference between running on a 3D cache versus running on a regular CCD is not that different, which is fascinating. But running just on 3D cache without hyperthreading is excellent as well. And that one competes. Honestly, that one competes with running all cores with hyperthreading, with all cores minus the hyperthreading on all CCDs, running just the non-3D CCD1. So turning off 3D cache, running just on non-3D CCD, while with no hyperthreading, all excellent results. And you can see it in this video here, the deep dive into affinity scheduling. But Windows 10. Windows 10 there's something amazing about it. I don't quite understand. And as close as I got it to no stuttering here, there's still something going on here. You don't even really see it, like the fluctuations are not even happening like visually here, but it drops. So there's a high probability that Windows is using your system for telemetry, for checking your data, taking snapshots of your disk image without approval. There's nothing new, honestly, man. I would say if you're on 7950X3D right now, as of September 3rd, 2024, install Windows 10. Don't go for Windows 11. It sounds absurd, right? But go for Windows 10. And your performance, yeah, like you'll lose some average. Your average is not going to be 192. It's probably going to be like 180, 175. But this here will not happen to that extent. And run the frame pacing that's at much better speeds, like 11.5 or whatever. This is the same stuff, bro. Like and this Windows 11 has been tuned, by the way. So on Windows 10, right, I want to show you some stuff too. So device manager. So I disable high precision event timer, virtual drive enumerator, Hyper-V. Unless you're running virtualized systems, don't have it on. High definition. It's really interesting too on the Windows 10. You don't have a lot of virtual shit, which tells you what? There is less virtual shit running in the background. And this tree of stuff is actually less compared to Windows 11. You can disable this. So anything virtual, unless you're running virtualization in some way. Separate systems through the same CPU. Boom, that's done. Nvidia settings. Control panel. So you can just copy it. Exactly how it looks. This can actually change. That's fine. Change it to prefer maximum performance. That usually gives you just a little bit more of a performance boost. So this is correct. 10 gigabytes, not auto. And turn off this threaded optimization actually will utilize your CPU from the standpoint you're not using hyper-threading, and turn off hyper-threading. And this will actually work really good for that. So have it off. This can be on for trilineal optimizations. It's kind of like going between, like it kind of like makes the textures less or less detailed. So it goes to bilinear here. From trilinear optimization to the bilinear texture filtering, which you can create shimmer. You can turn it off, but it'll take more resources. As you can see, higher performance with minimal loss of image quality. That's subjective. because it can alter it quite a lot, because basically what you're telling your system to render some images in a bilinear fashion, but it will improve your performance. That's that. Run Nvidia app, obviously. Don't run GeForce Experience because it hogs a bunch of resources. Where my driver at? There you go. Install 55585 Studio driver. Game rated drivers are kind of garbage. You can experiment with Windows 10 a little bit more, but the possibility of your frame-to-frame latency jumping up and down will increase substantially with game rated drivers. You'll have higher FPS. See what I mean? This is Windows 11, by the way. Current is less, but look at the average, 190. So anyway, you'll get more of a jumps here and there, and this will result in drops of 0.1%. And also, no more blue screens for me. I had all kinds of blue screens and shit like that. One thing to keep in mind too, by the way, make sure when you install your system, make sure your secure boot is turned on in BIOS. That your system is selected as UEFI and you have a secure boot turned on. Because what will happen is a lot of motherboards, I don't know why, they default to other operating OS, and secure boot is like custom or even disabled. And that can really cause some issues and not even allow you to install Windows. And once your Windows is installed, you can get a crash. So here's what I encountered, and I couldn't figure it out, but eventually I did. So if you go to event viewer, right? Select that, and you're gonna go to Windows logs, system. If you experience a crash and a restart, you can expand it like that. You can go to system. That's 1152. Look at this. So this is actually, I found another error. So it's the same error, but a different time, which is perfect. And that happened yesterday at night too. So secure boot update failed to update a secure boot variable with error. Secure boot is not enabled on this machine. And I was like, hey, what the fuck, man? Is that supposed to be a default option? So I went to BIOS and I could actually switch it. One thing to keep in mind, if you get this error and you got a secure boot error, make sure you back up your most important files. Because what can happen is once you switch to a secure boot, as it's supposed to be, and UEFI system from the other OS or whatever it's selected in the BIOS, it's BIOS specific, your system can stop booting. So essentially you can lose a bunch of data, and you're gonna have to either ask somebody else to put in that drive into a separate system to retrieve the data, because now you cannot access it because your Windows bootloader is not actually gonna load, and your Windows operating system is actually not gonna start. You're gonna be able to get into BIOS, which sometimes switching back to the same system that other OS and the legacy instead of UEFI, switching it back sometimes can help, but sometimes it breaks it permanently. So really, before you install Windows, make sure the secure boot is on. Make sure you back up your files if you notice this error, and random restarts. Because random restarts can happen for different reasons. Bad CPU overclock, anything. But I've been noticing, and it happens actually when it's idle. Secure boot. And see, like in some cases, it doesn't actually cause a restart. These two errors didn't actually restart my system. This one actually I was still up, wasn't sleeping, so it was still throwing errors. I didn't even know about it. 12. You see what I mean? But here's what the break is, right? You scroll down here. Where is it? Bam. So I kept the system on. I put it on to upload some videos. So at 5:24, I believe. Oh, okay. So I see what I mean. So previous system shutdown was unexpected. Unexpected shutdown. Okay. Critical. System has rebooted without cleanly shutting down. First error could be caused when the system stopped responding, crashed, or lost power unexpectedly. There's no power loss, bro. The reason is a secure boot. Somewhere, somehow, your system begins to lose its shit. This is in the morning. Actually, it restarted. It didn't actually shut down. Did a bunch of like memory dumps and stuff, and then it restarted. And then I was just using my computer normally around here. Like right here is when I flipped on my monitor and it was in sleep. So it did a restart. It didn't actually shut down. See, this stuff I need to take a look at. Registry hive recovered, blah blah blah. I'm gonna run a SFC scan now. Speaking of which, how to fix your computer when you have issues such as this? Type in CMD, then right click, run as administrator, then go CMD, actually I'm sorry, SFC scan now. And what it'll do, you'll scan the operating system for any kind of data corruption, and it will try to correct it. So that's my verdict, guys. It's a good system. AMD is a good system, but it takes a lot of finagling. And if you're not ready to do what the fuck I'm doing here, get something else. Get a CPU with same type of core. I'm not talking about Intel, I'm not talking about AMD, I'm just talking about the structure. Get a 7800 X3D. Get a 7950X. If you have a weaker GPU, not RTX 4090, if you have, let's say, I don't know, RTX 4080 or 7900 XTX, you're fine with 7950X, just from a standpoint of not engineering this shit. Otherwise, you'll be doing the same stuff as me. You know? So that's it. See you guys.